Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Hello everyone, welcome to MLOps Live. I'm Sabine and I'm joined as always by my co-host Steven.
Hi everyone.
With us today we have Andreas Malekos and Ivan Chon-Hon, who are here to talk with us about leveraging MLOps technologies and principles at non-ML companies. So Andreas is currently the head of AI at Continuum Industries, and Ivan works as an AI engineer at that same company. And Continuum Industries is described as something that gives superpowers to your linear infrastructure planning and design teams so that they can design faster and build cheaper. So guys, welcome to the show.
Thank you. Glad to be here. Thanks for the invite.
Yeah, thanks for having us.
Awesome. Yeah, we'll get right into it. So Ivan, you have an engineering background, right? And Andreas has more of a physics background. But can you tell us a bit more about yourselves and how the two of you came to meet?
Sure. I guess I'll kick us off. So basically, we met through a sort of student engineering team. So I'm not sure if what's my favorite question? Do you know what Hyperloop is?
I have not heard of it until now.
Hyperloop is this sort of thing that like Elon Musk, of all people, kind of suggested sort of like quite a few years ago. It was meant to be a transportation system, a high-speed transportation system, where essentially you would put pods in a sort of vacuum tube and you would put people in those pods, and it was meant to be like an even higher speed rail because the pods would be in a vacuum, right? And essentially, SpaceX started organizing student competitions every summer, sort of engineering university student competitions every summer. Edinburgh, the University of Edinburgh, where we both studied, had a team competing in those competitions called Hyped, the University of Edinburgh Hyperloop team. And I think, Ivan, you were part of the team since... so maybe 2016 or
2017, yeah, I think.
And then I kind of joined the team a bit later on. I think around 2017, I was back from a year abroad in Switzerland. And I had read about the team during my time abroad because they were already active in doing things. And I just walked past like the pod that they had built the previous year. And I was like, oh, I think I've seen this. And I walked into and it was like a lecture. And then I messaged them saying, I want to join the team. And that's kind of how we met. We were both part of the simulations team, we basically simulated, I think, most of the pods like systems. And then from that team, the company kind of spun out initially as a Hyperloop software company. And after many, many, many U-turns, we have now ended up as the company that we are now and with the mission that we have right now. That's kind of like the short story of how we met.
Mm-hmm.
That sounds very interesting, and it does sound like one or two U-turns was required there along the way. Right, so getting into your current company, could you tell us a bit more about your roles there, what you do?
Sure thing. So maybe just briefly to talk about the company first. So Continuum Industries, we basically are building a platform called Optioneer that allows civil engineers and other stakeholders to, as you said yourself, rapidly design linear infrastructure assets. So by linear infrastructure, we mean things that sort of connect A to B, things like water pipelines, things like overhead transmission lines, onshore power cables, offshore power cables. So all of these types of pretty critical infrastructure. Our platform Optioneer gives engineers more data earlier in the process and allows them to design these infrastructure assets more quickly and in a more open and transparent way and in a collaborative way as well. My role within the company is that as head of AI, I basically lead the part of the technical team that essentially works on two aspects of this sort of problem. The first aspect is the sort of computational engineering aspect, which is essentially all of the different engineering models that go into defining this sort of engineering problem. So costing models, technical parameters, things like knowing how much it costs to go through a certain type of land, what kind of, when you're sort of building an onshore power cable, what kind of installation methods you're going to use to install this power cable. So all of these things, that's one aspect of it. And that's the aspect that is exposed to our users, and our users can go into our application and select which design assumptions they want to take into account. And then the other part is the sort of AI part. So all of these computational engineering models get fed to this AI optimization algorithm, which then generates candidate alignments of these types of linear infrastructure and suggests solutions. So I lead the team that basically works on both of these things, and I help maintain the roadmap of features that is related to that part of the product. And also as a developer, I think these days I work mostly on sort of end-to-end features. So bringing out some of the cool stuff that is being developed by Ivan and some of our colleagues all the way out from our sort of AI service to frontend, to users. That's my role.
Yeah, on my end, my role is mainly focused on the algorithm, the optimization engine that we use to drive the product. So I in charge of monitoring, testing the algorithm, and then as soon as it's ready for production, I also work on deployment as well. Yeah, that's pretty much my role. And then, yeah.
Awesome. Yeah, we'll dig into all of that deeper very shortly. Before that, just a bit of housekeeping. So just a reminder, this is an interactive Q&A, which means that if you're here with us, you can just raise your hand if you want to ask a question from our guests, and we will unmute you and you can go ahead and ask. You can also leave your question in chat and we'll pick it up as soon as possible. If you want to be anonymous, you can also DM me in the Zoom chat and ask your question that way. All right, Stephen,
Yeah.
dig in.
Right. These are really interesting use cases. And I think it will be really good for us to look at some of these use cases. Let's deeper into some of them. And then from there, set the tone for the rest of the episode. So you mentioned some interesting problems around optimization, if I'm not mistaken, and all of that. Could you sort of give us like a use case and maybe walk us through how you go about thinking about the problem first off and then solving that at the high level, of course?
Yeah. Okay, let's try to keep it at the right level. So essentially, at the core, the problem we're trying to solve is a pathfinding problem. So you have like your starting point, which could be an offshore wind farm, and then you have an ending point, which could be the landfall, where sort of you want to route the power cable that's going to bring power from the onshore wind farm all the way on land. And the question is, what's the best path for that cable to take, for that asset to take? It's quite a complex problem, because for two main reasons. The first one is that there are a lot of stakeholders involved in this decision. There are people that their primary focus is building this as cheaply as possible, right? There are people whose focus is building this in the most environmentally friendly way possible, and also minimizing the environmental impact of whatever it is that gets built. That's like a huge concern these days, as you can imagine. And then can also be people representing local communities. You know, when you have sort of a big an overhead transmission line that is being built, you will very often need to engage with the communities and make sure that the impact on them is minimized. So there's all these different stakeholders, and that will obviously push the sort of correct solution in completely different directions. So you have to try and manage all of that. And then the second thing is that basically it can be quite a problem that's quite difficult to model, because the data available, both in terms of sort of real geospatial data, like information about what is actually in the path of what you're trying to build, but also in terms of costing assumptions, it's very often unclear. So both of these things are quite a nebulous problem, and that's why employing some of the more, what I would call traditional pathfinding algorithms, like sort of non-AI, let's say pathfinding algorithms, are, we think, not as well equipped to deal with that. And this is why sort of we have approached this problem with AI in mind, and more specifically using a type of AI called evolutionary sort of computing algorithms. So not machine learning algorithms, but rather evolutionary algorithms that are able to take these different stakeholders' positions into account and sort of explore a wide range of possible alignments, possible options, and then give you essentially a bit of different series of compromises between the thing that, say, one stakeholder might care the most, all the way to the thing that another stakeholder may care about the most.
Great. And of course, it's the AI part of things that I believe our listeners are a lot more interested in. And I'm not going to pretend I'm an expert in evolutionary computing. And I would just love you to walk us through how you sort of apply this technology and why you think it's the right fit for such problem space.
That's because the problem that we're solving, I'm going to go into a little bit more technical terms here because it's hard to explain it. So the problem that we are solving is very discrete. It's not continuous. Most traditional optimization engine tend to optimizing on a continuous base, but whereas our problem is very different to that. It doesn't apply to it. And as Andy said previously, our problem is also multi-objectives. We want to actually balance between all different the components that we are using, balancing all the objective, as well as the problem has a lot of constraints. Given how complex the problem is, we found evolutionary computing is probably the best way to solve it. It's not going to produce the absolute best solution, but it approximates a really good solution. And those good solution is way better than what we have in the engineering space right now.
Basically, the last point that Ivan made is a really important one, that essentially finding the most optimal solution in a problem that is not an accurate representation of reality is a bit of a pointless task. You'll find something that is maybe the most optimal, but an engineer may look at it and say, well, maybe your algorithm says it's the most optimal, but I don't agree because there's all these things that I know that are not taken into account. So what becomes more interesting in that case is to have a diverse range of solutions that explore different things, and then the final decision is left up to the engineer. And that's where evolutionary computing algorithms, who look at the generation of solutions and they basically optimize multiple solutions at the same time, that's where they really shine.
Perfect. And let's sort of address the elephant in the room here right now. I'm thinking of this disconnect between evolutionary computing as well as maybe that's more research focused type of application, and then taking that sort of application and putting that into production. Of course, this is where like the MLOps comes in. So where's that disconnect for the team between like using the algorithms, the evolutionary computing algorithms, and then practically turning those into products that serve the end users?
Where is the disconnect? This is a problem that I think a lot of machine learning companies face, where you have sort of your data science team and then you have your engineering team, right? And there is sort of a gap, right? And we've tried to sort of keep that gap for us. So we don't have a data science team, but we have the engine team, the AI team. So, and that team is split into two. You have the AI engineers like Ivan, and then you have what I would call maybe the computational engineering model engineers who build the actual engineering models that go into the AI. And we've tried to keep the gap between these people and the rest of the engineering team as small as possible. So I don't think that it has not been a huge concern for us, sort of disconnect. We've tried to keep this gap narrow by essentially treating everyone the same. So treating our AI engineers, our computational engineering engineers as software engineers. So going through the same practices of pull request reviews, of, everything, of good coding practices, like making sure that everyone is aware of like how to use tools like Git, and also making sure that everybody is aware of the wider stack. Even if you don't get to use sort of things like kubectl commands, or if you don't get to code on the front end, just being aware kind of how that works really helps a lot when it comes to actually that part of the team being able to contribute to code that goes into production without there needing to be an intermediary, like an engineering team that takes the work of that team and sort of has to kind of translate it via sort of into actual productization code.
Yeah. Especially we're a small team that actually really helped speed up the deployment of our models and then testing as well.
Yeah, being a small team has actually worked in our favor because we don't have enough people to come in and sort of plug that gap. It has to be the people that are actually working on the digital engineering models, working on the algorithm, that actually push the code out to production.
That's quite interesting because compared to other teams, right, there's no traditional focus on ML. Evolutionary computing is a separate part of AI in this particular case. And, when we talk about MLOps, we have this traditional focus, like, these models and algorithms and systems that are actually specific to ML. Right. And I just want to understand, what's your experience in implementing MLOps in your case as a non-ML company and not even using traditional ML techniques?
So it's been quite an interesting path, I think, because as you said, we're not an ML company. So we never really looked at machine learning and what happens in the ML space for solutions. And we didn't even consider ourselves to be an AI company at the start. It's kind of been a process of like realizing kind of where we sit on the spectrum. So we initially started just kind of fresh out of university with, I think, the assumption that we're going to build an algorithm and it's just going to work. Like, you do a uni project, you build the thing that the uni project asks you, and it's just going to work, right? And then you move on to the next thing. And so that was sort of how we're thinking about it initially. But I think over time we realized that there are a lot of challenges that come with a relatively complex algorithm being put at the center of a product. You might not always You're basically throwing problems at that algorithm every day that are unseen problems. And you're not going to be there to tune it manually every time. You have to understand, how is the algorithm performing? Is it doing well? You have to be able to tell when you make changes, how those changes impact almost all of the use cases that your algorithm tackles. And this is where sort of you start to see the similarities between what we're doing and what sort of MLOps tries to solve. So the process for us was that basically we started off by saying, okay, we have to come up with a way to test this algorithm that is more than just us looking at the results. We have to come up with something more automated. And so we initially built a very bespoke and very custom, it's not even a pipeline, it was a fancy command line interface that would essentially run a bunch of test cases and then kind of upload the result from these test cases. And then we would have to go in and kind of manually see like what's going on. And then I'm not even sure how it happened, but we just kind of stumbled onto the field of MLOps. And we're like, oh my God, like this has been here this whole time. And it's a big chunk of that offers the solution to what we're after. So I think our first experience was using Neptune. And that was purely meant to be a sort of experiment tracking. And I think back then, Neptune was sort of marketing itself also as an experiment tracking tool. I think now, as the field of MLOps has emerged, I think Neptune has also positioned itself as an MLOps tool very successfully. But back then, what we were looking at was just experiment tracking, right? So we're a team of like AI engineers. We run a lot of experiments with our algorithm. We do hyperparameter tuning. We do hyperparameter searching. We have different test cases, and we want to basically organize the mess of notebooks that we have. And Neptune was a good sort of tool. So we just started using that. That was our first sort of step. But then the problem grew, basically. We're like, okay, we want to do more. We don't just want to track. We don't just want to sort of have this experiment tracking. We want to automate more things about how we test the algorithm. And then eventually we want to start monitoring this algorithm. And that's when we started, I don't know, for me, I was working on a side project, which was sort of an NLP side project. And I came across, I think I was using the Spacey library, which is like a pretty standard NLP library. And I came across integrations with things like Neptune, integrations with things like DVC, which is this data versioning sort of Git-like tool. And then I started thinking, a lot of this stuff is really, we could really use this. We don't have ML training data, but our algorithm uses geospatial data to run the optimization. So for us, data is just as important in many ways as for ML. It's just in a different way. We don't use it to train the algorithm, but it's essential to the results that the algorithm returns, because what's on your map tells you what your costs are, basically. And then things just kind of came together then, and we started adopting these tools, I think, one by one. So starting with DVC, and then sort of moved on to GitHub Actions, I think, to sort of construct a pipeline where you have your data versioning, your run monitoring and tracking, your sort of model deployment, like AI deployment sort of framework, and bringing all of that together. And I think it's still kind of bespoke, but we're sort of using these tools to essentially now have this kind of automated pipeline where we do have reports that are being generated every week, essentially, that are sent to us, and they're saying how the algorithm is performing on some sort of set test cases. So it's been a bit of a one step at a time, I think, and where every step we kind of have to think about, right, we're not an ML company, but here are the tools that ML companies use to solve this particular problem. Can we use these tools, or do we have to make something bespoke? Basically, like because these tools will never be exactly what we need for our use case. But the question is it enough, or are we just better off building our own thing? And so we're still in the process of, like, with every step forward we take, we ask ourselves that question.
Absolutely. Yeah.
Yeah, I think it's quite interesting the way you sort of found out. You didn't just think of ML as this holistic part, or you just a holistic thing, but you just kind of figure out, oh, what's this component that's absolutely crucial for us right now? For example, experiment tracking, and then you went on to like the data side and so forth. I'm just sort of curious in terms of, like, how do I call it, like the priority that you found, like, for example, these components, these MLOps components, which ones have you found that has been absolutely crucial to, solving, your problems? Of course, beyond, let's say, experiment tracking one, but what other components have you found that as part of the MLOps, let's say general components, or should I say part of MLOps, that you found that has been really useful to your problems and use cases?
Yeah, for me, actually, data versioning and data tracking, because something that we experienced at the beginning is the data acquisition for the geo data. It get updated somewhat regularly, and very soon the data will be outdated. We need to update them. To update them, we need to make sure the model is compatible with that, and making sure that is the correct one that we use to tune our algorithm on. So using things like DVC, like the versioning controlling the data, is actually really helpful for us in terms of like monitoring and testing it, our model.
Okay, actually, interesting that you picked that. I think I would say this is very important, but if I were to think of something crucial, I think it would either be, like a sort of a Neptune style metadata store where we use it for different use cases. We use it as an experiment tracking tool. We use it to monitor our algorithm in production. We use it for automated tests. So I do think of it as something that kind of sits at the core of what we do. But then also I am between that and our actual sort of the way that we deploy the algorithm, which is that we use Argo workflows, which is a sort of cloud workflow on Kubernetes, kind of like orchestrator. And I think that when we adopted that, there was really like a step change in ease of use, or ease of deployment, but also in sort of the scalability of, because we integrated more than just the optimization step into that workflow. We also integrated certain pre-processing that used to happen in sort of web servers that were not very stable. They didn't scale very well. If you had like a web server that had to process in like several gigabytes of geospatial data before sending it over to the optimizer, that, for example, was something that would fall over very regularly. And by basically taking different bits, putting them in a workflow that would just, you spin up a bunch of instances, you run every step of the workflow, and then it kind of shuts down and goes away. We both, I think, reduced our costs and managed to be able to scale to a lot more jobs being able to run at the same time, because you don't rely on like what your server can do. You just spin up compute, almost like serverless, basically, architecture. You spin up compute as you need it, and then you shut it down.
Yeah, that's interesting because the way you're describing this, I'm thinking of, something that's a lot more native to MLOps, and this is the pipelining process. So are these sort of workflows arranged in a pipeline sort of, or, this is like, it's just a manual process? I'm driving towards your MLOps blueprints now. What level of MLOps you're in at this point?
Yeah, so that pipeline is the pipeline that runs on production. And that is like, that's again, where we're kind of different. We don't have a training step in our deployment pipeline, but each job is its own kind of like, it's almost like if you were running a reinforcement learning task with every customer would run like that's probably the closest thing I can compare it to. And so there's one pipeline that does that on production for every job that customers submit. And then we've got the testing pipeline, which uses a different workflow orchestrator, which is GitHub Actions, that is more about testing and validating the algorithm.
And you mentioned testing a few times. How is that different from more traditional ML focused testing, the way you test like your evolutionary computing algorithms?
So I think there's two big differences. The first one is that we don't have a training step. So there's just no training step. And then the second one is that we don't really have labeled data in the way that for a lot of ML companies, you've got your ground truth, and then you train your ML model, and then you use the ground truth to calculate whatever accuracy or F1 or recall, and then you use that to sort of drive your training. And that's what your ML pipeline does. And at the end, you get like a pickle file or like whatever metadata is relevant. Instead, what we have is we rely more on sort of statistical tests that are sort of before and after statistical tests. And by the way, the reason we don't have ground truth data is because when you try to solve like this kind of routing problem that we do, there's not really a way to automatically tell, is this a good solution or not, without actually having an engineer to come and look at the result and really scrutinize it. It's a really difficult process to automate. So because we lack this ground truth data, so we can't just say, here's the result of the optimizer for this known test case this week. Like, how good is it? Is it correct or not? Like, that question is very difficult to answer for us. And that kind of prevents us, I think, from having like a full-on sort of automated pipeline. Instead, what we rely on is the before and after test. So what was this result like last week? What is it this week? And then we do this basically across a range of different test cases, and we run each test case many times, and then we do statistics essentially on the before and after, and they tell us like, is there a statistically significant difference between what we have now and what we had last week? Mm-hmm. And then if there is, and if it's good and we're trying to make it better, then great. If it's bad and we didn't know we had changed something, then it's bad. And that's kind of the core of our testing pipeline right now.
Yeah, interesting. How about the engineering tests? Do you run? I know you should run in some engineering tests. So that is like a unit test or
Yes,
is
so
around that?
we have
Okay.
we have unit tests for everything, and we have sort of integration tests for everything. But this, maybe I should have clarified that this aspect is specific to what we call the algorithm tests. So they're not unit tests; they look just at the final outputs of the algorithm, which is the objective function, the constraints data, and then some other diversity metrics, and the comparison is done at that level.
Awesome. Ivan, do you want to say something?
Yeah, I was going to say
Okay.
there's one more challenge that is different to traditional ML in terms of testing is for more traditional one, there is always heuristic, a metric to measure exactly the performance of the algorithm, like accuracy, that kind of stuff. For us, that metrics, we don't have one. We kind of have to rely on something that we come up with. It might not actually work, and we kind of reiterating it over time. So that is another challenge that we have in terms of testing.
Yeah, that's very true. So we have to kind of come up with our own sort of metrics for that stuff. They don't always work. So it's a process where you have a metric and then you look at it and you're kind of assessing two things. You're assessing, according to this metric, are we doing better or not? But then you're also actually assessing how good the metric itself is to measure what you're trying to measure. So, and very often you find that the metric is not that good or easy to interpret.
Those are great points. It does sound like a lot of hard problems to to solve in this case. Anyways, the team for taking this on. And I just wanted to jump, of course, to the team real quick. And how's the team structure like Continuum right now that's really enabling solving these problems?
We are a company of about 30 something people. About half of that is the technical team. And then about half of the technical team is the sort of AI team. And so the structure is pretty basically the CTO and myself kind of co-manage the technical team. The CTO kind of manages from a high level the entire technical team, whereas I kind of lead specifically the AI team. So that's kind of and then apart from that, it's pretty flat structure in terms of hierarchy. In terms of sort of expertise, the AI team itself has with quite a wide range of expertise and of backgrounds. And I think that has actually helped us overcome some of these challenges a lot. So we've got people that are such as Ivan, that are more focused on the AI itself. And we've got our computational engineering engineers. And then we've got a couple of generalists, which I would put myself, I think, in that category. And basically, it's that sort of having these different backgrounds allows us as a team to basically operate like any other engineering team without there being this difference between like a data science team and an engineering team. Because Ivan and I are going to work together on some AI related feature, with Ivan sort of usually leading the charge, doing the heavy research, implementing a lot of the code, running a lot of the tests. And then I'm sort of familiar enough with the sort of algorithmic side that I can sort of take that and do the sort of last mile of the sort of full on bringing that to the front end. So we have sort of certain team members that are more focused on one part of the stack. And then by leveraging the generalists, we are able to bridge that gap because I have just enough knowledge to be able to, and just enough context to be able to sort of take the work that's being done in one part of the stack and bring it all the way out in front of users.
Awesome. And has your search for MLOps as sort of like an holy grail changed the structure of the team in some sense or informed the structure of the team?
I don't know, Ivan, what do you think?
I would say we formed the structure of the team kind of around it. So we kind of form the structure around it. So everyone has to get familiar with different parts of them. They don't necessarily need to know everything about ML or how our pipeline works like the back of their hand, but they need to know the certain part of it. Like if something's go wrong, they can go back and see and track it and then talk to the relevant people as soon as possible. For me and Andy, I think we know the pipeline really, really, really well. So if anything happens, anyone in the engine teams not sure about it, they can just talk to us and then work around with it. So does that make sense?
Oh yeah, that particular question. On the infrastructure side, did the team particularly build a platform for MLOps itself, or how do you power MLOps sort of?
How do we apply MLOps on the infrastructure side? How do we do it? Yeah, there's different bits, I think. Different parts of our sort of MLOps stack are deployed, I guess, in different ways. So we use the sort of infrastructure as code through Terraform to install things like Argo on our cluster. The Argo workflow is sort of server and controller and the actual definitions, which are then deployed when we actually run our CI/CD pipeline. We have our usual YAML engineering that comes along with that to sort of define the pipelines. And then we are sort of monorepo the entire stack. So basically everything is kind of deployed together, like the whole application, including the algorithm test, including the definitions of the workflow that gets submitted on production for the production runs, the GitHub actions, all of that is like part of one repo. And so it gets like the deployment procedure is pretty harmonized across all of our different services, including the sort of more AI service.
And is that on a cloud platform or
Yeah, so it
on-premise?
runs on AWS, more specifically EKS, so the AWS sort of managed Kubernetes service. And yeah, like everything, we've got sort of 3 different testing, production, development accounts, and the 3 don't talk to each other. And our testing pipeline, actually our algorithm testing pipeline, I think runs sort of half on production and half not. So the compute, I think, I think it may be run entirely on production because there's some sensitive data that goes into basically geospatial data is usually something that a lot of our clients and customers like guard very, very, very dearly because it's quite expensive to acquire, and good geospatial data can be very valuable. So a lot of this data cannot leave production. Sorry, I'm going on a bit of a tangent here, but that's just to say that as a result of that, our testing pipeline has to run on production as well, because the data that it uses is classified as sensitive, and so it cannot leave our production systems.
Right. Awesome. Thanks for sharing that. I think it's time to jump right into some of the questions that were pre-submitted by community members. This person asked, could you share examples of how you successfully integrated MLOps practices into the development lifecycle at a non-MLOps company? I think this is,
Yeah, of course we can. I mean, I think the first version of this testing pipeline is probably a good example where there was a lot of newness coming into the stack. And I think I was the one at the time that was sort of going around in circles, trying to figure out how can we crack this like testing pipeline. And I think regular communication with the rest of the team, especially with Ivan, because in a way, like Ivan was going to be the user of that pipeline, and the person in the company that benefits most from it. And it's going to be like his work that will have been made easier, and sort of keeping him in the loop and also getting his requirements. So basically treating it almost like any other sort of developer-client relationship. And then like a lot of walkthroughs. And then once that pipeline was deployed, sort of slowly but surely making sure that he familiarized himself with that part of the stack to the point now where, if something goes wrong with the pipeline, as Ivan said, you're able to kind of come in. Like I'm not the sole kind of like owner of this pipeline anymore. And it's like sort of almost fully on Ivan now. So I would say that this sort of example is just making sure that the people that are going to be using the stuff are sort of have the time to become familiar with it to the point where then they are, because also I think you learn a bunch of stuff from it. I don't think you knew how GitHub Actions say worked or anything like that at the start. And now it's something that you're sort of, I don't know, what was it like from your perspective?
Yeah, it was actually very interesting. At first, we were trying to build something ourselves, actually, at the very beginning. But then after the introduction of the MLOps, the whole thing is actually making it a lot simpler than it was. And it got a lot easier to use and understand after understanding a little bit more. And then eventually it just fully integrated into my day-to-day work, really, like the whole experiment tracking and then testing and monitoring pipeline.
Yeah, so awesome. There's a lot of evangelizing, I guess, that goes into it, and sort of preaching and making sure that you're loud about the fact that this is happening. Because if you just do it, then you kind of like dark deploy it, and then I might have ended up being the only one that was using it, but it's not like just for one person. So you have to make sure to spread the word in a way to the people that are most relevant. And then in time, everyone will become familiar with it, essentially.
It just may be one thing that I skipped during the team conversation as well. I think what I envision is a major problem, even in ML companies, is that cross-team collaboration, whereby even if they're like, there's a data science team working on one use case and another ML AI team working on another use case, there's still that problem of communication. Now, I think, of course, you can correct me if I'm wrong, but I think that problem might be sort of escalated or even prevalent in cases where you're working, that's in an AI team, working cross-collaboration with another non-AI team. How do you sort of fix that communication gap between both teams?
That's a very good question. And indeed, it is a problem, especially because the problem we're solving is fairly very sort of technical, and it's not always clear what users are after and what will make a good solution versus a bad solution. I don't think we have one thing. I'm not sure I'm even going to pretend that we have fully fixed the problem, but we've definitely made strides, I think, towards addressing it. And I think there's lots of little and medium things that we do to help here. So first of all is that we use Slack for pretty much everything, and we use open, public Slack channels. So everyone is kind of aware of what everyone else is doing. So the AI team has access to channels related to our customer success team, which are sort of our internal users that have the sort of use case knowledge. And so we sort of have this kind of transfer of knowledge that kind of happens in a bit of an implicit way. We've got presentations from the customer success team to the rest of the team as well, where they will come and they will talk about the way the software is being used by our users. And again, that's to build that additional context for the whole technical team. But I think in a way, we need to know about it to sort of understand what makes the users tick more than like other technical team members. Mm-hmm. And then I think it's also my job, to be honest, to bridge that gap and to bring, when we discuss features, when we discuss feature development priorities, it's also my role to sort of have that context as like not just a developer, but also part of the leadership team of the company. And sort of I am exposed non-technical conversations, and sort of I have a thing and understanding of the clients in the wider business context that I can bring to these discussions. So there's a lot of like human effort, I think. I don't think there's like a framework that we use or like a technology that we use that helps us. It's just the team gelling, I think, and sort of making sure that everyone's talking to each other about the things that matter.
Absolutely. I think the transparency in the team is definitely key, like for me as a developer for the AI model. Knowing what the internal user or external user think about our product and think about our algorithm, like how it's performing, like the first-hand feedback is really, really useful. It makes me think, like when I'm developing and when I'm adding new feature to the algorithm, it makes me think what would be actually the best way to do it. Is the things that I'm developing right now actually relevant to the user? So I think that transparency is the key. There's no framework, there's nothing, there's no framework to encourage that as a whole, as a team, that actually helps.
We involve our customer success team very sort of intimately in our development process, and they help us set the development priorities, or they help us sanity check, basically, is what we're developing the right thing. So they're especially like when we are developing radical new algorithm features, we need them there from the start to make sure that we're working on the right thing. So basically it's involving the right people. I think if I had to summarize it, it's involving the right people and your end users, or people who can speak on behalf of your end users as early as possible, so that you're not sort of wasting your time, basically.
And when we talked about tooling earlier on, I think one of the major things that people would love to learn is really how you decide, sort of like evaluate and choose the right MLOps tools to use. And how do you go about the process? Just give us a framework as to how you think about that.
So we usually start thinking about the problem. So what problem are we trying to address, right? So, are we trying to make sure our data is treated the same as our code by versioning it? Are we trying to solve scalability issues in the way that we deploy our algorithms? So it starts with that. And then, to be honest, I don't know, Ivan, maybe you have a different perspective, but from my perspective, what has helped is having these problems in mind, and then just kind of, sometimes you will try to look for solutions to these problems, but I think for me, most of the time, it was just having these problems in my head, and then just making sure you have your eyes open and your ears open and just doing new things. And then you will find something that you'll be like, okay, this thing, it will help solve this problem that I've been thinking about. So for me, we have this thing, sort of learning days. Basically, each month we get 2 days to just learn about something, to work on side projects, stuff like that. And for me, that has been kind of instrumental. I think I will start learning about something that is kind of like adjacent to what we're doing. So I will be using Spacey to do like an NLP project. And then I will see something there that I know can be applied to what we're doing. And then that'll sort of be a thread that I can basically pull on and uncover a bunch of new stuff. So it's more about being doing new things, I think, and exposing yourself to new frameworks, to new technologies, and then having the sort of problems that you're trying to solve at work in your head. And then you will see how these things can be applied.
Yeah, I think I agree with that. That is pretty much sum up how I discover a lot of things that we're using, a lot of tools that we're using.
Yeah, so I think in terms of framework, the learning days, I think really useful, and they're completely optional. Some of our developers take them more often than others. And as I said, I think for us, definitely on the engine team, on the AI team, it's been kind of essential, because in the day-to-day of trying to work towards your product roadmap, it doesn't always feel like you have the time to learn something new. But then when you have this 2 days a month, if you want, take them and learn them, it almost always benefits the company and the person doing the learning in some way.
You just never know what's out there. And just when you stumble up on it, and that might be really helpful for your next project or next task that you have. That pretty much like sum up how I come across all of the packages that we have been using in our development stack.
Yeah. So how about the build versus buy decision process? What you think you can do in-house, and then, what you think, hey, I could just buy from a third-party vendor or some.
Yeah, I mean, I guess that's the big question. And I guess it goes beyond like MLOps. I think it's with any tool. Do you build something bespoke? Do you go for the open source, but I have to maintain myself? Or do you go for the fully managed? I think it really depends on what the problem you're solving is and how much time, what the actual cost of the solution being provided is, how well that solution fits to your needs. And then if you were to not go for a solution that is kind of managed and where you have to kind of like buy, what is the sort of cost in terms of hours and manpower that will have to be spent on developing and maintaining whatever it is that you end up building? And I think that sort of second bit, the cost there can be very insidious because you're like, oh, well, it's free, isn't it? And then you have to spend like a full quarter like developing it. And then 1 year later, you might have to spend another full quarter maintaining it or upgrading it, right? But sometimes that's what you need to do because there is no solution that works well for you to do. So it's really problem depend. I think what has worked for us is like a mixture of the two. I don't think we have one approach, always buy or always build our own stuff. It's kind of like, yeah, it's very case dependent, basically.
All right, that's a good point. Thank you for sharing that. I think I just want to jump into something rather crucial just before we wrap up the episode. And that's on the post-deployment side of things for ML, because I think that's usually those components of MLOps is what people usually consider crucial. With ML companies, you think about monitoring the models that are there in production. And how do you think about monitoring those models you've deployed or those services you've deployed and stuff?
This is one of the most crucial and one of the most difficult problems for us, because that is where the lack of accessing a ground truth really comes back and bites us. So if I were to use like a dumb example, Deliveroo or Uber Eats or something, and you're sort of monitoring the model that predicts how long it's going to take for your order to get there, right? Your model makes a prediction, and then eventually your food gets there. And then right then and there, you know your ground truth, right? Like you just say, that is how we would have predicted. And at some point, the Uber driver or the delivery person got there, and that's it. And I can store the ground truth versus the predicted time, and I can build like I can use that to update my training database. I can do whatever I want with it, right? And I can build like all sorts of fancy pipelines around that thing. That is the thing that for us is not, and as Ivan was explaining before, we don't really have a ground truth. So a user submits a case, it's a new part of the world with previously for us, unseen geodata. They configure their own models however they see fit, and then they run something, and then they get back a result. And there's no way for us, like the moment the result is generated, there's no way for us to automatically tell, so was this a good result or not? And then use that information and like kind of backfeed it into our development process. So this is, I think, the problem that we have not managed to crack just yet. We've made some steps, I think, in that direction. So we are sort of monitoring every run production. We're recording data about that run. We are recording images and plots that help us further down the line. So it's not really for a lack of infrastructure that we sort of have not cracked that, but rather a lack of like what. It's not like how to measure, it's more like what to measure. So we do use like tools like Neptune for that as well, where we can measure like the progress of the optimization. We can see whether we found solutions that are feasible or infeasible. We can look at the final objective values that we came up with. But it's information, but we haven't quite cracked yet how exactly to use that in an automated way and build like a really robust sort of monitor on production kind of pipeline. We have all the data, or we have some data. We're just not sure if it's enough. And also we're not quite sure what to do with it just yet, like in an automated way. I think that's kind of my summary. I don't know, Ivan, what do you think?
Yeah, that's true. Yeah.
Yeah, and speaking on that, I think earlier in the episode you mentioned something about this being a continuous solution, space. So, and does that mean that you often update these models? Maybe if you detect some deterioration, maybe during like your evaluation stage, you update these models, or how do you update these models largely as the data changes over time, if it changes, of course?
So I don't think we don't suffer from like, say, data drift in the way that I think some ML companies do, where the underlying, I think, world, I guess, changes. And so your data, your sort of training data is like frozen in time. What we do, I guess, suffer from is a drift between what the algorithm can handle and how complex the thing that is being optimized is. Because our sort of computational engineering team, they're always adding stuff. The computational engineering team is throwing more and more difficult problems at the algorithm. So where the drift always comes from is that we have to basically make sure that the algorithm keeps up with the complexity of the problem that's being thrown at it. And in terms of deployment, as I said, we have a monorepo, everything's being deployed at once. We have a YAML definition of this sort of workflow that we run. And that is when we want to change something, we update the code or we update the parameters in that YAML that sort of are the hyperparameters of the algorithm. So again, and I think, Ivan, maybe you can add here as well, like we can only deploy one kind of quote unquote model at the time right now.
Yeah. So at the moment, we can only deploy one model to production right now. So that really significantly limit us from doing things like A/B testing, like that kind of stuff. It could be really difficult. So we are actually looking at different MLOps tools and see if anything that can help us to do such a thing.
All right. Well, it might be a good moment to wrap up today's interview, unless there was anything that you wanted to add, any follow-up?
I'm not sure. I guess that we're definitely not at the end of our MLOps journey. As Ivan has been explaining, especially like monitoring, I think is going to be key to us, not just being able to understand what our algorithm is doing on production, but also in terms of scaling the amount of projects that we can deliver, the amount of users that we can have, being able to understand what the algorithm is doing across hundreds, if not thousands of users is definitely crucial. So there's still a lot to learn, and the field is also sort of developing at like really sort of breakneck pace. We're just in the process now of like reviewing all of the stuff that we spent the last hour sort of like explaining to you about our testing pipeline. And yeah, we're just excited for the future, I guess, of the whole field. And even though we're like quite a niche in the typical use case, I think that's also what makes it very interesting, is that we have to try and find our way in this like plethora of different tools and frameworks and approaches to this problem.
It's an exciting space to navigate for sure. So Stephen, was there any last questions that we could squeeze in?
Oh, absolutely. I just wanted to know from Ivan and Andreas' perspective, what are some of those tips or practices you would say that you give anybody, doing or practically applying AI, ML in non-ML ML companies and stuff?
So I think what I said before about basically keep the problems in your head and then just do new things, and you will find solutions to stuff that you didn't sort of know. And then I think the other one is to just take it one step at a time, because it can be it's a new field, it's a pretty large field, there's a lot of things happening. So try and start from one place. So maybe you want to just start tracking your experiments. Maybe you just want to start versioning your data. Don't try and do everything at once. Just kind of start in one place and just kind of see where you go from there. And then lastly, I think don't forget that there is a community out there that you can always, especially because a lot of these tools are like Argo workflows, even Neptune or DVC, they're quite niche tools. Your usual Stack Overflow tricks might not work, where you just Google if you run into a problem. So all of these tools, they've got communities out there on Slack, on Discord, on whatever. And just reach out and ask if you've got a question. And in my experience, people do come and answer. So don't hesitate to ask for help and guidance, and you will find the users of these tools are more than happy to come and provide guidance.
Yeah. On top of that, for me, I would also add, learn new things, learn new frameworks, learning new packages, like learning different library. You don't know if they're going to be useful, but when it does, it's going to be really, really helpful. Like whatever task that you're working on, just learn new things. Don't forget to do that.
Awesome. Thank you so much for sharing those points. It's been a great conversation today. Thank you.
Thank you very much for having us.
Yeah, those were some excellent tips. And for anyone who might be wondering where to start with seeking out the community, the MLOps community Slack is probably a good starting point if you're not there already. All right. Thanks also from my side, you guys, for coming on and sharing your expertise and practical tips. So before we wrap things up here, is there some particular way that people can follow you or get in touch with you, connect online?
We're both on LinkedIn, I think. So just Andreas Malekos, Ivan Chan.
Chon-Hon.
Yeah, on LinkedIn. I do have Twitter, but I only use it to read threads about politics, so not sort of. And then the company itself, Continuum Industries, got a LinkedIn profile. So LinkedIn is probably where we're at.
Awesome. We'll see you guys there. In the meantime, we'll be back in 2 weeks, and next time we'll have with us Delina Ivanova, and we'll be talking about managing data and machine learning teams to deliver value. So a bit more on the management side of things next time. So in the meantime, see you on socials and in the MLOps community Slack. Take care. See you next time. Thanks.
Thank you very much.
Thank
Bye.
you.
Thanks. Bye-bye. MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.